Welcome to section 3.4, selected problems. Here we're going to take a look at the difference between a permutation and a combination. In both cases, we're going to be looking at two new variables, n and r. N is the number of distinct objects, and r will be the number of objects that are taken at a time, numbers taken from that sample set. A permutation order will matter. This will be, for example, in a swimming race, a bike race, an election where you have a president and a vice president. Combination will have the same variables n and r, but here order will not matter. Examples of that would be, let's say I was choosing 3 people out of 10 to form a committee, all with equivalent positions. Order would not matter. Some of these we're going to answer true and false for. A combination is an ordered arrangement of objects. We've just mentioned that a combination order does not matter. A permutation would be a combination, would be an ordered arrangement of objects. The number of different ordered arrangements of n distinct objects is n factorial. We're going to see this utilized with slight variations in some of the other problems. Let's take a look at some of the calculations that we're going to perform. Permutations follow the formula of n factorial divided by n minus r factorial. In this case, n factorial is 9 factorial. And of course, n minus r, which would be 9 minus 5, would be 4 factorial. So I'd have 9 factorial over 4 factorial. Well, 9 factorial is 9 times 8 times 7 times 6 times 5. Whoops. Running with a mouse is never easy. Times 4 factorial. I can divide this whole thing by 4 factorial. The 4 factorials, of course, cancel out, and I'm left with 9 times 8 times 7 times 6 times 5. And combination formula is very similar to the permutation formula, except for instead of having n minus r factorial in the denominator, it's n minus r factorial times r factorial. Let's determine whether the following are permutations or combinations. The number of ways 8 cars can line up in a row for a car wash. Here order obviously matters, so it's a permutation. Think about it this way: if you're online, you feel that you should be able to go before the person who comes in after you, so order does matter. The number of ways a 4-membered committee can be chosen from 10 people. Because none of these committee members hold any different positions, this is a combination. Let's go down to these types of problems. 8 people compete in a downhill ski race. Assume that there are no ties. In how many different orders can the skiers finish? Well, we can recognize this is 8 factorial because order matters, and there's 8 members in there. In how many ways can the letters A, B, C, D, E, and F be arranged to form a 6-letter security code? Security codes have to be entered in a certain order. There are 6 items here, so this again would be 6 factorial. The starting lineup of a softball team consists of 10 players. And how many batting orders are possible using the starting lineup? Again, this would be 10 factorial. I'd like to give you some that are better sample problems of what you'd be seeing. The starting lineup for a softball team consists of 10 players. And how many different orders can you select who's batting first, second, and third? Here I'd see only 3 members that would be batting. So I'm going to put 3 lines to represent each. There are 10 possible people who could go first. There are 9 possible people who could go second. And 8 possible people who could go third. Best to be done is 10 times 9 times 8. True, you could have used the formula 10 choose 3. I'm sorry, 10 permutation 3, 10p3. But it's easier to use it set up this way, which is basically the counting principle. You have 7 different video games. How many different ways can you arrange the games side by side on a shelf? How about if I said how many different ways could you select your favorite 2 video games? Your first favorite video game and your second favorite? Well, that would be 2 possible because there are 7 video games. There are 7 to select for your favorite and 6 to select for your second favorite, giving a total of 42.